31.
All right, we shall get started then. So right now, I know a lot of people aren't back yet, but we'll get started. Um, we have the panel overview by Amy and Sherwin. So what we're gonna do is go through that, and then after this, we're gonna have a little working session. So everybody, if you want to do it now, open up Revit 2019. Let's see if you don't have to follow along on this first part of it, but we're gonna be using Revit in the second part of it. Sounds good. All right, I'll throw it over to Amy. Amy, feel free to share whenever you're ready.
Alrighty, thanks, Gabe. Yeah, so like Gabe mentioned, that we're going to follow this with the training. So if you didn't get those files copied over, I'd say go ahead and do that now. And like you said, get your Revit going so we can jump into that. Hopefully we have plenty of time. And this is me with Sherwin's group. I met with the whole team, kind of last notice, sprung it on them, or late notice, and a couple of the guys were able to put together a video, so we're going to get into that too. So first, let me get this show started. So this, of course, going with the theme of staying connected, right? So where are we now? Where were we? What, what's going on with metal panels? There's a lot of stuff happening and continuously evolving. All right. So,
Amy, 1 second before you start. We're seeing your presentation.
Oh, sorry.
Like the other side of the screen.
Why did it do that? I told it to share this one. Okay, maybe. Okay, thank you, Gabe. Okay, cool. All right, and then I'm going to put in the chat. Let me get this open, and we do have a Jamboard link down there. So if you guys do have questions along the way, the chat that we've been using in the meetings has been great, but this, if we use the Jamboard, other people can see the questions too. And at the end, when we go over that, if we have time, and if there are any questions, then we can walk through them all together. I just think it's a good way to have everybody see what everybody else is asking. And the chat works fine if you do want to ask questions in there, but we want good visibility on what you're asking.
You gotta be careful with the Jamboard because only 25 people can go in it. So if you're gonna drop something in on the Jamboard, do so and then leave so that someone else can jump in. FYI.
Okay, great, thank you. And yeah, and if you do find that your question gets answered, you could clean it back off there or whatever. But yeah, we'll see how that works.
Is there a link to the Jamboard?
There's a link in the chat for this presentation down in the Zoom chat. Okay, all right. So current state, what are we doing? So right now, panels are being modeled at the bid phase in the sales model. We're getting that data collected for the estimate. We're going to talk about that a little bit. If the project moves to operations, we have had drafting team members and panel team members taking over the updating of those panels. They refine that scope, and then we end up handing off that data to the fab team. And so we'll talk about that too. So that's all happening right now, and it's always evolving. Okay, so in this presentation, we'll talk about how we're modeling in the sales phase and what that involves. We'll talk about some of the latest modeling tools. We have 3 styles to choose from currently in the library. We'll talk about how to choose the best tool, and these are what we have now. It's not the only way to do any of this by any means, but trying to come up with the standard and keeping it reasonable for what we want modeled. We'll just talk a little bit about that. But key to anything that we do develop are parameters and other requirements so that the takeoff program can read those panels and get the data to hand off to that team. And I need to move this thing out of my way. There we go. And then again, the panel team is going to come in. Jared and Andrew put together a video that's really great, talking about their process then and now. So that'd be really cool to see. And then we'll follow with the Q&A. All right. All right, so at the sales model phase, what we have, when we're modeling for a bid estimate, there's key points about creating a sales model in this early phase that it's good for people to understand. First of all, the team is modeling panels based on the design information available at that time. And as you know, when you have drawings at bid, when it finally gets to the handed over to operations, if we get the project, a lot can change or a lot can get clarified that was not very clear in the beginning. So understanding that they're trying to get panels in there or curtain wall or anything else to capture scope and give the estimators a really accurate estimate for materials is what we're trying to get at that phase. There may only be a rough set of contract documents in PDF. We may have an architect's model, there's all kinds of different situations. One project that we worked on recently, all we had was a Rhino model, which is basically comes in as one big mass, and it was maybe 25% complete. So there's all kinds of different scenarios for when we are starting these models and getting these panels in there. But they get that scope in based on their best assumption, discussing it in the daily huddles with the estimator and Jumpstart and everybody that's involved. Again, there may not be specific joints indicated. Maybe all we know is there's a big canopy there and it's metal, it's aluminum, it's panel of some sort. So we got to get something in there, but it could be really rough.
Amy,
all the sales model.
I don't think we have access to the Jamboard. It doesn't have public access, so just so you know. But we can just do the questions in chat if you want.
Well, I like to see them. Let's see, where do I set that again?
You sent it to me, Amy.
Did I? Let's see. Sorry, guys. There's always something that goes.
I copy pasted it and it says you need access.
Okay. So there we go. Now I got it in the chat. Everybody, yes, yep, everyone should see it now. Okay. And then I forget, where is the way to set the settings for this? Share. Okay. Get this thing out of the way. Get changed to everyone, not restricted. Anyone with the link. Okay. Can somebody test that out for me? Zach, you want to test it? Just
looks like it works.
There. Okay, great. Thank you. Yeah, yep. Thank you for letting me know.
Sorry.
Yep, no problem. Okay, cool. So yeah, and so lastly, all the sales model tools are designed with a lot of options built in, whether it's the curtain panels or metal panels or anything else that we're doing. Those families that we're working with have a lot of potential flexibility built in to accommodate a lot of situations so that those guys get that thing modeled as quickly as possible. So that's what they're built for at the very beginning, is to help with that situation, whatever might come up. So the point of modeling, I got a typo at this phase, is to capture scope. So how complicated is this project? How many panels are there? And what are we dealing with? So we get that all modeled up. We go ahead and we get the material data for the pricing. So here you can see all of the different paint colors, all the different panel counts in this case, because we do know where the joints are. We have a total panel count, and we have total square footage, because we have a formula in there that's actually counting that unfolded shape, getting all that panel surface as accurate as possible. We do a 3D PDF, and that looks like this. And we provide that, there we go, to the sales model team, and we get that into the Bluebeam session so that they can spin it around and provide it in our bid package. Okay.
Sorry, Amy, to interrupt again, but the Jamboard is view only. We can't add anything to it. Sorry.
What? It's okay. What's going on with this thing? So I said share. Anyone can do it. Anyone with the link.
Make sure it says anyone can edit.
Okay. Yeah. There we go. All right. Thank you.
Thank you.
Onward. Yeah. Okay. And then let's see. Lastly, we want to set up the downstream teams by having that model started for them, so they can start in on shop drawings. They could start creating elevations, getting views on sheets, and then they're just refining that model as it continues on. And then tagged panel drawings. So the panel guys are going to go over this in their video. So now we can have these tagged panels. And if you zoom in on this, you'll see that every part has a number. And this is based on developments in that takeoff program. So they'll get into that. Okay, so some of the latest modeling tools. Again, this is high level, like we said. I'm just going to run through this stuff pretty quickly so that we have enough time for the rest of the demo later. But everything we're talking about here is on the wiki or on the portal in the training, on the training page there. The Revit adaptive panels, panels using curtain panels, and parapet caps. So the concepts and the tools. Okay, excuse me. So when we use curtain panel families for flat walls, we use curtain panel families for parapets, fascia panels, soffit panels. We use adaptive families for the non-rectangular, non-planar, unique, bendy, twisty parts. So when we're using the curtain panel families, that is the fastest way to get a panel wall built in. A couple ways to go about it. You can build a mass and apply curtain systems and curtain grids for the panel joints. You could build a curtain wall and switch out that glazed panel with the appropriate metal panels. So this is all still stuff just to kind of experiment with and find what works best. But in the case here, I'm just going to play this video. It's going to show you, let me get this out of the way. It's going to show you, can I start it right from here? Let's see if it's going, yeah. So it's going to show you building on a mass. So there's a mass created and I'm putting a curtain system on 3 different sides of this building. So you select them and you say create system. All right, so I'm working with a system, a wall that has no preset grids. I just grabbed one that already exists, but you don't want the grids preset in there because you're going to say where the joints go. You're going to put your own joints in by doing the next step, which is adding those curtain grids. So we're just setting up where those panel joints are going to be. So here I'm selecting that first panel and I'm going to put a flat panel in the middle of there. And you can see it starts out with the big red X because it's oversized, but there are options for whether it's composite or plate, what the material is, and what those panel joint sizes are. And then we start adding our curtain grids to create it. And you can see the X's go away because now we have panels that are reasonable. You can see how easy it is to edit where those grids are and just get those joints in there. Okay, so now, again, if you have to go back and change something, you can either edit it because it changes all the time, or you can delete a grid, add a grid at any time. So again, seeing that, oh here, yeah, right, this part. So I'm taking that glazed panel and I'm switching it out for empty. You don't have to leave that stuff in. It's better to get it out if you don't need it. And we're going to put a B-type panel where there's the fold on the right side in there. And then I'm just going to adjust that right side fold to be that to the center of that joint, the 2'6". And now I'm just going to add the grids up the side to make those same joints. I'm not being super careful about it right now because I'm going to go back and use the align tool to get those panels around the corner to line up. Lots of different ways to go about it, different methods. On the other side, I'm going to take that panel out again there and just make it empty. And then we'll put a 2-fold on this side. So you would use this for column covers or anything else. So there the left side's already set to 2 feet. I'm setting the right side to 5 feet and I'll add those joints in. But yeah, this is a good column cover family right here, the 2-fold. Go ahead and align all of those. Okay, so we got our panels in there. Now, if you edit that mass and the wall moves, this is why masses are good and they're supposed to work. And I know there have been some issues with this and we still have to track this down, but I'm moving the face of that wall out. And when you pick on the curtain system, you can tell it to update to face and it will move out to that new location. So having it associated to a mass should be a very quick way to be able to modify it later on. And it gets all the corners, it pulls all the panels, it moves all the panels with it. If you have separate curtain walls, you would have to adjust each curtain wall separately to do that. And then here I'm just going around and setting that bottom joint, doing a little refining, setting that bottom joint to 0. Same thing at the top. And last one. So you can pretty quickly get something built using that tool. The last thing to note, it's set to plate panel by default, but plate panel and composite panel have different maxes for before it gets more expensive. So you can see right now I select that smaller panel. If I set it to composite, actually what am I doing? Let's see. Yeah, set that to plate, make it 5'10". So when it's plate, it's fine, but if I select it and switch it to composite, it now exceeds the composite standard size. I mean, it's met the maximum. It doesn't mean we can't get it. It just means it's going to cost more money. All right. So, oops, sorry. Curtain panels for parapets, fascia panels, and soffit panels. Again, this is a very fast method to get long runs of panels in, eyebrows, things around the top of the building, using that same thing, using a curtain panel. I got to get it right. There we go. So now I'm going to add a parapet. So I know I need to work on level 3. So I'm going to go up to level 3 and I'm going to create a wall, just a very short wall around the top, 8 inches, 6 inches. Again, this is one method of doing this. This doesn't have to be done this way, but this can be very quick. I've just got to have some reference planes in there that I'm working to. And this is what we're going to be doing in our hands-on today. Getting that curtain, getting that parapet cap in there. Okay, so I have my little wall built. I'll go to my 3D view and I'll go ahead and set one of those panels with the parapet cap family. And then I'm going to go to my plan view and I'm going to check the wall section and make sure I have it where it needs to be. So I'm going to move it up by 3/4 of an inch so I get a joint under there. So you can plan your panel family around this, or you can move the bottom of the wall up. Now I'm going to match the rest of the walls to that same setting. And then I'll switch out the rest of those panels. Just going to select all, switch it out. Now I'll add some joints by just adding some curtain grids. Again, I'm not being specific about where they go. And right now we have left and right outside corner families, but this is an area we're definitely going to improve on. Gabe has a good trick for making some mitered parts that we're going to probably incorporate into these families so we have fewer families. So, but for now we have a left and a right outside 90. So I just switched those out. And you can edit those families and change the miters. And the last thing I'm doing there is just aligning those joints. Of course, that last little panel is really tiny. Okay, it's not necessarily realistic. All right, so adaptive families for non-rectangular planar panels. This is the slowest method because each corner of the panel needs to be placed manually on a pick point. So it typically requires a lot more layout, and it should only really be used when none of our other families or any other style of modeling works, but it is great for those unique situations. And I just made it go past it. I'm in trouble playing the videos. All right, there we go. So I'm just going to show you, I'm going to create a mass here of that hexagon, whatever it is. Yeah, shape, 6 sides. So I'm putting a profile at the bottom, and I'm going to copy that profile to the top so that I have a profile that I'm going to twist at the top. So first thing I'm doing, again, this is all covered later, but I'm building a basic mass, and I'm going to create a form. All right, and go ahead and I'm going to grab the top of that, and I'm going to spin it. Just to get a little twist on it and show you. All right, so now we're dealing with this more complex shape. So the next step is to understand where you have to lay out the joints. That's what I'm saying. This is a slower method and a lot more layout. We've created these surfaces that we're going to apply a curtain system on, but now we also have to tell it where the joints are going to be, and you need pick points on those faces. So I've made these reference planes and I've named them, and you need them to be named if you want to use them later. And what we're doing is we're creating where the joints are, and we're going to project those onto these surfaces so we can get those intersection points to be pickable. So now we go back into the edit mass mode, and I'm just going to grab one surface and use the divide surface tool, uncheck the default or unselect the defaults, and we're going to use that intersects list. So the intersects list are those named reference planes. So we go ahead and say that, and then we also want to tell the surface representation to be nodes and original surface. If you don't check original surface, it disappears. I just kept it in there just cause. So again, I'm going to do the same thing here. Go ahead and uncheck the defaults, grab my reference planes, and tell it to have some dots, nodes, so I can pick. Now, if you try to do more than one surface, this is the thing that I think is kind of a bummer. If I select multiple surfaces, I still have the option to divide surface, but I don't get the option to turn off the U and V grids. So I'd have to look further into that. Maybe there's another way to do it. but basically you have to do one at a time. Again, making it slower to lay out. So you get that whole thing done. So now we're all good to go. I've got them all laid out. And when you go to elevation south, you can see all those joints are lining up on those reference planes. So, excuse me, now we're going to go in and we're going to place some panels. And whenever you want to place adaptive families, you need to be in the edit mask mode. And we'll just we'll put a triangle one in here just to show. You don't have to use, fill the whole thing up. I could just have a triangle panel in there if I want. And so these panels have the same options of joints and material, all that stuff, but it works a little bit differently. Joint 1 is on the bottom, joint 2 in this case is on the right, joint 3 is on the top. There's no, I can't do joint bottom, right, left, top, all that stuff in these panels because they can go in any direction. So you just have to know that joint 1 is from point 1 to point 2. Joint 2 is from point 2 to point 3. We have that all documented. It's all in that, mapped out in that instruction sheet on the instruction manual. Now I'll place a 1-fold, so it's going to go around the corner. It takes a little bit longer as we pick these points. It's thinking about building that panel. So Revit is understanding how it needs to twist and turn this shape. So that's why it's slower. And then you do have to be careful when you go to pick those points. Sometimes you can accidentally pick on the edge of something else or whatever. So you do want to make sure you're getting onto those points. And then I'll just set that bottom joint to 0. So joint 1 and on a 1-fold wraps all the way around. So that whole bottom offset is associated with that joint 1 parameter. All right, so then we'll go ahead and see, what do I have next in this one? Okay, I'm going to go to the elevation and I'm going to adjust that joint. So this is where the layout can pay off. If it ends up the architect wants to move that joint, all we have to do is move that reference plane and that panel, the panels will shrink and grow with it. So even though there was more layout, it's not a total loss. So you can still make some updates later. And we'll put one more panel up here at the top. Pick those last points. It's thinking about it. I picked on that one a little early. It still found the right spot though. You definitely, it's best to wait for that little grip snap thing to show up. And you definitely do want to pick in the proper order. There is an order to these pick points. So now I'm going to edit that mask. I'm going to go back into that level 3 and I picked that top surface when I was in 3D and I'll just rotate it some more and we'll see that those panels do move with it. So again, updates are easy. And then the last thing, I'll just grab one edge just to show you again. Now I'm just grabbing that one edge of that mask. And it goes with it. So they're really flexible. They're a very different setup for a family. When you go into the family itself, it's a lot more complicated. All of those nodes have to know which direction they're supposed to face. They all have to be very specifically set up. So it's definitely a more complicated family to set up, but it's super flexible. Using soffit panels making soffit panels is a sped up, really quick version. So I'm just going to hide those upper frames. I'm going to go to level 2. I'm going to create my little wall. This is one method. They don't have to be done this way. I've also seen them placed on a surface underneath with just using our typical flat curtain panel family. But this is just another way to get something like this in there. So now I'm going to go to the section view and I'm going to just adjust where the offset is. That panel has some adjustments in it. So there I'm just saying move the face back 8.5 inches. It's a little big. It's not realistic for a caulk joint, but just showing you that there's flexibility in parts like this. And then I'm going to bring that guy forward and make it 3'6". Now I'm just going to add some joints by adding those curtain grids. And then we'll just use the align tool to get those guys to line up with the framing below. And again, all of this material is being counted and is all usable information. So there's our little soffit panel. Okay, so working with the data for the takeoff program to recognize the panel, it has, as a family, it has to have the is_WW glass panel parameter in there and checked. And there are 4 other parameters that we use. So is_WW glass panel is a type parameter. The rest of these are just instance parameters. So they can be used by the drafter or the fab team later on down the road. All minor surfaces and folds need to be painted, quote unquote, painted a different color than the main faces. So this means anything that we don't want, we'll talk about this again, but anything that we don't want the takeoff program to take off because the panel fab team is going to deal with it, we want all of those to be ignored by that program. So we've made this, the material, and we paint it, and I'll show you that in a second. All folds are 0 radius, no curve, no filleted corners, no rounded broke, press broke shapes. It's all square. So we get that geometry right for takeoff. So if the material isn't already set up in the family when you get to the project, you create the material called takeoff ignore panel face, and you use that paint tool. And so that's how, here's how this works. So you go to materials, and you make, or so you can see it's already in there. If it's not, we set it to yellow so that it's very obvious. That is very specific in its case sensitivity for the takeoff program. So you want to get that right. So then we go into the paint tool and we just start painting all the surfaces that we want that takeoff program to ignore. Okay. If the panel family has more than one panel, these are things you've got to remember. Like if you want to make a new family for something, if the panel family has more than one panel profile, each part requires its own extrusion within the family. So this is really important for the takeoff program as well. Get that video to come up. There we go. So this is an eyebrow example. So very fast to make this a curtain panel family to make a long run along the top of the building. But again, when you're in that curtain panel family, make each shape its own extrusion. So you can see it's a little profile down there. If I go to 3D view, you can see it's its own extrusion. And each of those needs to be painted properly. That is what allows the takeoff program to be able to tag the different parts. So the takeoff program reads the main faces of a panel or points in space when it's non-rectangular, and the panel fab team adds the panel returns based on the details when it gets to their phase. So those surfaces there, we want the takeoff program to read. All the little tabs we don't necessarily care about. On the back side of this parapet cap, we want, we've got even the drip leg, I'm leaving it in there for now. But we don't have to worry about the ends. So at this time, we're not making a lot of we're not making unique panels for every unique condition on the project, meaning if you have a lot of flat panels in a soffit and you get to a corner where there maybe needs to be a notch, we're not concerned with modeling every one of those panels. Elements like notches can be noted in the part instance by adding a note to the panel fab number parameter, and that's this guy right here. So when you select on the part, there's something that's supposed to happen different there. You put a little notation in here, and when it gets read by the takeoff program, it goes into their database, their data format with a little flag for them to see that there's something unique going on here. That's where we're at now. We'll see how it goes and see how the process evolves. So key things to remember. Each panel family needs the 5 takeoff parameters. Use the paint tool to paint any surface the takeoff program should ignore. All folded corners are a 0 radius, no filleted corners. If there are multiple panel profiles in a family, each one needs to be a separate extrusion. And then don't forget to constrain each one at the end of your panel, at your reference planes. Once a model moves into operations, this is really an important thing that we want to work on and help make the process smoother as we transition into operations. We may start the sales model with these families that do a lot and flex and are able to accommodate a lot of things. When it gets into operations, if you don't need it to still do that flexing, you don't need to maintain all of those parameters. If you know it's become a final shape at a specific size, just get it to that size and update it, and you can remove dimensions or any kind of other flexi controllers that you don't care about. This is where you can do a little interpretation and figure out what's best for what's happening in the project once it gets handed to you. So simplify that model update by making that profile the final shape. So future state, making miter panels and parts more dynamic and flexible is definitely on the radar. Add a few more family types. We'll see how that goes, potentially with notching options or things like that. So that's part of that continuous improvement in working with the different teams as we evolve this process. So now the panel fab team has an awesome video. I'm going to hand this over to Jared, or I'm just going to let go of the screen for now, and I'll hand it over to whoever's controlling that. Sorry, guys.
All right, thank you. Just 1 minute. All right, here we go. Oh, and thank you for joining us today. We're going to go over the new panel process for 2020, brought to you by your favorite panel team. This year, the panel team has been working on an all-new approach to how panels are made. With the help of Zach, Alan, and Amy, we've gone from the sales team all the way through to the fab tickets and changed our whole process. What we're going to cover today. We're going to cover true size panels straight from Revit where they're accurate. We're going to cover the key sheets that we can create in Revit. We're going to cover the takeoff data that we can now get out of Revit and transition straight to Inventor. We're going to show you how we make our fast panels in Inventor and our new and improved fab tickets.
True size panels. This is a term that is new, and we're using it that is geared more towards the new process of how we're making panels. It basically says that all the panels that exist on a building will and should be that size for what the field is going to end up using. Because before, with the old method, we would have to use a lot of shop drawings in terms of plan views and elevations and details to try and coordinate where this panel would exist while visually looking at a transition detail but not actually being able to see it as a 1-for-1 ratio. So a lot of the stuff that we would get would just be theoretical. We would either send it long or send it short depending on how big it was, but most likely send it long so that the field can just deal with what they need to and make it work, which wastes time from their end, just so that we also don't spend so much time trying to figure out what was correct using the old method. But now with the new method, all the panels that are on the building are sized with the correct joints, cock joints, and everything that would mean that once it translates into fabs and parts, that would be what's exactly used in the field. No more send this long and just have the field figure it out or cut it short kind of thing. It really saved us time that was spent trying to figure out the panel, what the panel is doing, figure out what the panel is doing versus now being able to see what the panel does and go into production much sooner. It would save, I think, with all the layouts and getting the dimensions and whatnot, it would take at least a day or two in terms of trying to put it all in Excel and gather that information where, what floor it exists on and everything like that. But with the new data coming from the takeoff program and it being modeled to size, it saves us a lot of time and a lot of room for error to be closer to finishing the process for checking, which then, if that's mostly correct, then once the checker's done, we do minimal updates and then just release it. And that's kind of the end goal, is that what we get from the beginning is correct. We have to just double check it, send it out for checking. Checking sees that it's what it's supposed to be, and we barely have to do any updates and release it. That's the ultimate goal for us with true size panels. Key sheets. There was quite a few methods that we could do it in the old way, but a lot of the times it ended up being that we would have to uh, apply mark numbers um, in a certain layer, and so you would create a text and have to make sure that that text was on the correct tag layer, so that when you hit, for example, LMM1 on AutoCAD, it would show the panel tag layer, and if your mark number did not have that tag 3 that was required for when you print, then they would not show up when you print sheets. And like that, we would batch print, which means you would either have to replace one or reprint them all, which again, a lot of it was just very tedious manual labor that took a good amount of time for us to create. With the new method, thankfully now we're gearing more towards like an 80-20 process, where it's now just grab a view that exists in Revit, put it on a sheet that we can categorize separately from shop drawings, and print it to be ready to send for checking, with a few clicks of how to display the mark numbers on the sheet. So it's really sped up how we create our key sheets, and it eliminated a lot of the tedious work that could end up having errors, which is like a mark number sizing is off, it's placed too far to the left, or there's some of them end up overlapping depending on how it's printed. So um, it's really benefited us having this new method with Revit, making key sheets. In this video, we'll be discussing how we used to do our panel key sheets and how we currently are doing our key sheets. As you can see from Matilda Commons A, we're going to be using the portal panels as an example here. There's 3. There's one in the north, one in the south, and one in the east. And so we would need to look around the shop drawings and the elevations to find where the portals are, and possibly extract the area from the portal on the elevation. And then once we create the sheets, we would place mark numbers, make sure it's on the right tag, so when we print, you could see it from the tag layer that we used for panel mark numbers, which was the LMM1 function in AutoCAD. And so it left for a lot of room of error if you were to place mark numbers and forget to change them into tag 3 layers. But now with Revit, we're able to create views or grab views that are in use, make a sheet that is separate from the shop drawing set, and place mark numbers that were already given to the panels by the takeoff program. As you can see here, we have the category panel key sheets. Here I have all three views of all the portals. So I would highlight a panel, make sure it's the main family, not the child family in the case of this building, which would show a mark number, which we can then go to the tag all, select the multi-category tag, and it will apply, it will show the mark number, and then you just select the panels all around, make sure that you've chosen the main family. So as you can see here, it chose the child. That was a mistake. So we reselect it, retag it, and there's the mark number. And then I would just do the same for both. And that's pretty much it.
Takeoff data. The old way, we didn't have one. We didn't have no takeoff program love over in the panel team, but now we do. The new stuff. Data for the typical panels, data for complex panels. We can now easily track our quantities. We can set up and add distributions, all straight from Revit through the takeoff program right into Inventor. So with the takeoff program, we were given our own button to export our parameters. When we do that, it provides us Excel files like this for all of the priorities that we have currently set. It will sort by distribution as we set it up. It'll track total quantities. It'll sit there and keep individual quantities. It will even give us per panel its own mark number. We are now given all of our data as needed. It will categorize the panel shape, all with a new and improved takeoff program for the panel team. Fast panels. All right, the old way, we had to create panels one by one manually. Sometimes it was quick, sometimes it wasn't. Sometimes we could make them data driven, but in order to do this, we had to make an Excel sheet, plug in all of the information that we could gather from drawings, layouts, shop drawings, plug it all in, and then maybe we could get it done, maybe we couldn't, with an iPart. Now, the new way, we get the data straight from the takeoff program. It's data driven. We can have reusable panels. We can use tables that are generated from the takeoff program's data that's provided to us. And in the future, we can possibly automate the entire process or a large majority of it. Here's a couple videos of the old way and then the new way. Enjoy. They are fast paced, so bear with us because we're trying to squeeze it into the time.
Let's make some panels the old way. So we're going to make a portal panel right down here at the bottom two. First, we're going to open up our shop drawings. We're going to start looking for the profile. Then we're going to find out what page has the best information for us to make a layout. So our profile's on 351. That's the full panel. And then 205B will be the CAD drawing that we pull up in order to make our layout. So we're going to lay out panel 108 and panel 110. So I've already went through the liberty of finding the links. Did that by the profile down here and the top profile up here. So full layout. So we have our overall face links for these two panels. We have,
that's confusing.
right here, our profile. That was right here. I went through and dimensioned everything.
I think it's
There
intended
we
to
go.
be.
So now that we have our profile, our face link, we have the data we need. Now we can start. Now, going to open a new CAD drawing. going to set the default thickness for sheet metal. And start drawing. We have our face length right here. 98 3/4 and 19. We'll just put the 19 inches for this example. And there's the panel.
That was cute.
Okay, that was just the old way. You can see how complicated that was and how much time it took just to make a panel. Now, the new way, if you blink, you might miss it. It's going to be quick. And here it is.
Creating typical eye parts is easier than ever. For this example, we have a C2 as the panel shape. This is the data that the takeoff program provided us. Since we already have C2s made, we can simply just copy and paste the data in. So what we're going to do is we're going to open our current parts, which is a C2, right here. We're going to do a quick save as. This time we're just going to save it as a C2, right on our desktop. We're going to import our data, that way it's attached. That'll populate right over here. We're going to take our data, we're going to copy it. And we will import it right into our table. You can notice the part change. We have multiple parts in this one, we have 4. We'll do a quick check. And that is it. Now all we have to do is add a couple flanges for our connections, and that's it.
Improved fab tickets. In the old method, we would have to start a fab ticket, import data that is necessary, place the views, add the dimensions, add notes, and then create the data table, which we would then have to determine how many columns are necessary, how many rows are necessary, and then make the data look the way it needs to be. The whole process of transitioning from the generic table to the final product of the table using Excel, which had a lot of the data that we were using, takes up time. Time that could be used to move on to the next part if it's already there. And so then if you had to make a new fab ticket, you would have to then repeat the process. Now, if there was a way for you to be, luckily, sometimes we'd be able to copy and paste it and reuse it. But a lot of the times the tickets were unique. So you would end up having to sometimes just start over, and it'll be quicker than trying to do a save as and adjust and modify, because it just changes too much sometimes. But thankfully with the new method, we have what's called iParts that can have multiple subparts inside of it. And there's tools that we can use now in Inventor to generate data that is more accessible for us. So when we place an iPart on a fab ticket, Alan helped us create a tool that allows us to create the files that exist in that specific iPart. So one iPart could have 5 to 6 different subparts, and the Create Tools tool will generate all five of those parts with a fab ticket attached to it. So if we set up the generic iPart fab ticket with the correct views and some dimensions or notes that we know that are going to be needed nonetheless, when we do the Create Tools, it'll copy those over onto the following fab tickets so that you have less things to annotate than you did before when you had to make every single one by itself. So it's cut down a good amount of time for the panel team having to generate the same data over and over again versus translating it now and cutting down the time that we spend on each specific fab ticket. Of course, sometimes there's unique parts and unique tickets, and so that kind of like, we can't get away from that. But being able to keep the generic parts, the flat panels, vertical panels, horizontal panels, being able to pump those out smoothly saves us time so that we can worry about the X panels or the mitered panels or transition panels, or panels that require more effort from us because they're unique, very unique I should say, compared to the typical panels, which can then just be spit out much more rapidly than before. So with the new methods that we're using, it has cut down our time a lot for making panels, which is really great.
Awesome.
All right.
Yeah, good job, you guys. That's so cool. It's very exciting. Let me see if I can get this to share the right screen this time. Let's see. There we go. All right. Yes. Thank you, panel team. That was super awesome. Again, you guys threw that together last minute, and it's just really, really cool. And I hope other people find it cool too. We'll turn over to the Jamboard in a second. And I just want to say, Juan, and I know a couple of other people have been doing a lot with testing out this process, and we've been doing a lot of back and forth, and lots of different ideas have come up. So I just want to thank you guys for helping move us along too. So there's been a lot of people involved to get this to where it's at, and it can only get better from here, which is super awesome. So that being said, we'll open it up for questions. Whoa, I thought there might be crickets on here, but looks like we have some stuff, and it looks like some things are getting answered. So can you guys see the Jamboard on my screen? Somebody just nod. Jared, can you see it? Yes, okay, cool, thank you. So let's see, what have I got? Panel team, if you want to unmute yourself and jump in on any of this. I'm not sure who's been answering these, but these I think are good answers. So I'm just going to say, what if there is a cut in the panel, or the panel needs to be a T shape? So this might be one of those areas where we we can note it in the panel fab number. These are good questions, and all this stuff will be good to follow through on, probably in more sessions, or maybe we have some training sessions on this stuff. What if the mass has to change? Sorry.
I wanted to just comment, Amy, on the first question that you asked with the cutout.
Yeah.
So there's two ways. With the fab number, we can put a 1N, like the fab team, like the takeoff team does right now, so that it'll kind of denote it in the takeoff program to make that panel separate. Or we could just kind of create a notch that already exists in the panel, and that would make it also separate from, say, the generic typical soffit panel. So there's two different methods on how you would do that. Yeah.
Sorry, who is we that would be creating the notch? Like the panel team?
Well, the person that's drawing the panels on the building.
So is that going to be the panel team or is it going to be the drafters?
Well, the experiment for Matilda was to include a drafter and a panel guy to kind of like get the knowledge for both teams, but I think ultimately it's going to end up going back to drafting to work on the panels for modeling.
Because I feel like, you know, we're asking drafting to be experts in a lot of things.
I mean, I'm not the one saying that it has to be that way.
So yeah, so these are
one very valuable drafter.
yeah, so these, I mean, all of these questions about some of this getting into the, you know, this stuff is all really good discussion. So where we started, just a little back history. The first directive was from Steve was let's get these panel shapes in there. Let's not worry about returns. Let's not worry about a lot of this other stuff. We want to get them in there. They're basic to get that data. Where it goes, I think it's definitely a bigger conversation, and we have like 3 minutes till our next thing. So this might be a good thing, Gabe. I don't know. You know, I know I'm supposed to do the demo for half an hour. I don't know if that can go into lunch and we want to stay here and get into these, because all these things are good questions that we need to answer, or how we want to deal with this or work with this.
I think we can kind of do the opposite. Like we can, you know, put a hold on this, get into the Revit, and then let people kind of play with it a little bit. And then if there's more questions that develop from that, we can probably talk about it during lunch.
Okay, cool. Okay, great.